Akrejola, be making a presentation on mathematical modeling and bifurcation analysis of hepatitis E virus genotypes 1 and 2 transmission with asymptomatic carriers. Please, the next slide. Next slide, please. Yes, the outline, we have an abstract, introduction, methods, result, conclusion, and recommendations. Hello. Then the abstract. Next slide, please. Next slide, please. Yeah, the background of the abstract. Hepatitis E virus, it remains a significant public health challenge, especially in low and medium income countries where genotypes 1 and 2 are predominant. The aim of this work is just to investigate the transmission dynamics of hepatitis E virus genotype 1 and 2 by explicitly incorporating asymptomatic carrier and environmental reservoir into a mathematical modeling framework. Next slide. We are to develop compartmental model that describe the transmission dynamics of hepatitis E virus genotype 1 and 2. The invariant region was derived, the disease-free equilibrium was established, and the basic reproduction number was computed using the next generation matrix approach. We also look at the stability analysis of the model and the nature of the bifurcation using the Zeta manifold theory. And then the results, we discovered that excluding the asymptomatic infectious class, there was a reduction in the basic reproduction number, which indicates that area significantly contributes to hepatitis E transmission. Now, the disease-free equilibrium was also proven to be locally and globally asymptotically stable when the basic reproduction number is less than 1. Now, we also studied the bifurcation analysis, and we discovered it forward bifurcation. Next slide, please. Now, the findings highlight the critical role of asymptomatic infection in the transmission dynamics of hepatitis E virus genotype 1 and 2. Now, incorporating asymptomatic carrier into hepatitis E virus model provides valuable insights and is essential for designing effective intervention strategies aimed at controlling this infection, especially in endemic settings. Hepatitis E virus is responsible for viral hepatitis. Is essentially the inflammation of the liver, with approximately 20 million infections annually and accounting for about 3.3% of viral infection-related deaths worldwide. Now, this infection is genotype specific. There is genotype 1 and 2 and genotype 3 and 4. Genotype 1 and 2 is the transmission route is fecal oral transmission, while genotype 3 and 4 involve a zoonotic transmission. And the asymptomatic plays a very critical role wherein those that are infected that are not showing clinical symptoms, they contribute in the transmission of this disease. Next slide, please. Now, the previous model have incorporated different factors, such as the sanitation. They've also looked at vaccine. Optimal control strategies have been studied. However, these models fail to explicitly include asymptomatic carrier and distinguish between hepatitis E genotypes, which limit their applicability to genotype-specific epidemiology. So what the aim of the study essentially is to develop a genotype-specific mathematical model for hepatitis E virus genotype 1 and hepatitis E virus genotype 2 that incorporates asymptomatic carrier and environmental transmission. Next slide, please. Now, this is the model equation. The equation 1 represents the model equation, the susceptible, the exposed, those that are symptomatic, and those that are not, that are asymptomatic. And we have the recovered compartment. We also have the environmental compartment, which is represent the population of the viral infection in the environment. And our first of infection is given in lambda 1 and lambda 2 with the following initial conditions stated in equation 2. Please, next slide.
Hello, sir. Are you there, sir? Are you there, sir?
Hello, can you hear me?
Yes, sir. We can hear you. Go continue, sir. Continue, sir.
Can you hear me, please? Okay.
Yes, sir. We can hear you, sir. You can continue, sir.
Okay. We also look at the disease-free and the basic reproduction number, which is given in equation 5 and equation 6. The equation 6 represents the reproduction number, and we decided to put this in three parts. The first represent the contribution of the symptomatic individuals, while the second represent the asymptomatic individuals' contribution. Then the arrow knot 3 is the environmental contribution. Altogether, the equation 6 represent the reproduction number. And we look at the local stability analysis of the disease-free equilibrium state, employing the always criteria. We're able to show that that the disease-free equilibrium is locally asymptotically stable when R naught is less than 1. This next slide. So we also look at the global stability analysis. In this case, we adopted the method in Castillo-Chavez 2002. So we were able to prove that the global stability is globally asymptotically stable when R naught is less than 1, which, next slide. Okay, this is also the global stability. This is from the equation 1, we're able to show that the unaffected compartment, we solve that equation as t tends to infinity. The fixed point is globally asymptotically stable, which verifies the first condition. In Castillo-Chavez, there are two conditions that must be satisfied. So the first, we proved the first condition was satisfied. Then we also prove for the second condition. Next slide. And we discover that K over K plus V is less than or equal to 1. It follows that our Y2, P1, P2 is greater than or equal to 0. Clearly, matrix M is an M matrix with the off-diagonal entries positive. Essentially, we just prove here that the disease-free equilibrium is globally asymptotically stable if R naught is less than or equal to 1 and unstable otherwise. Then we look at the bifurcation analysis. If we represent our S as S1 and so on, we have equation 12. Then the force of infection, here we scale the parameters. And using the Castillo-Chavez and Song 2004, the bifurcation parameters A is given as given in A and B. And after rigorous computation, we discover that A is negative, which is less than 0, and B is greater than 0, which suggests a forward bifurcation at R not equal to 1. Now the result, the basic reproduction number captures both direct and indirect transmission, with asymptomatic carriers playing a crucial role. Their contribution, their continuous viral shedding significantly increases the environmental component of R naught, making the environmental contamination a key driver of hepatitis E virus persistence. Both local and global stability analysis show that when R0 less than 1, hepatitis E virus transmission cannot be sustained regardless of initial infection level or environmental viral load. Then the model exhibits a forward that is supercritical bifurcation at R0 equal to 1, indicating a clear threshold between disease elimination and persistence. When R0 is greater than 1, a stable endemic equilibrium emerges, while coexistence of endemic and disease-free states for R0 is impossible. It is just because the reproduction number is forward bifurcation. Next slide, please. A deterministic hepatitis E genotype 1 and 2 transmission model with asymptomatic carrier was developed and rigorously analyzed. The basic reproduction number governs the dynamics, with the disease-free equilibrium being locally and globally asymptotically stable when R0 is less than 1, and a forward bifurcation occurring at R0 equal to 1, confirming a clear threshold between disease elimination and persistence. The analysis shows that asymptomatic individuals significantly increase R0 through sustained viral shedding and environmental contamination, making them key drivers of hepatitis. The hepatitis E virus transmission, even in the absence of overt clinical cases. Effective control strategy must be combined, improved sanitation and access to safe drinking water with interventions that reduce environmental viral load and asymptomatic transmission, including routine community surveillance and serological screening of both symptomatic and apparently healthy individuals to achieve sustainable eradication of hepatitis E virus genotype 1 and 2. These are the references. Thank you.
Yeah, thank you, Dr. Akari, for your presentation. So it's time for questions and answers. We have people who signify for questions. Online people, if you have questions, please signify. Okay. I'm just doing that. Number 1, number 2, then and also. Yeah, thank you so much, Doctor. And I just have some very some concerns with this work that is done. The topic says mathematical modeling and bifurcation analysis of hepatitis E virus genotype 1 transmission with asymptomatic carriers. And I'm struggling to understand the question of interest in this work. Like, what's the question of interest? What are we trying to assess? That's the number 1 challenge. Then number 2 is also that I can see that classical analysis have been carried out to assess global stability and all of the other classical analysis. But the results that came out of it, that as we are discussing the results, I was trying to see what's the link between the analysis that was carried out and the result that has been discussed after. Particularly if you go to the results, so you can go to the results and then the next slide after that talks about recommendation. Okay, so now this yes, for me, I'm looking at, well, this is an applied maths. For instance, say an epidemiologist who's not a mathematician, who is interested in this hepatitis E virus, and what can I make out of these results? Say R0 is greater than 1, is still endemic from emerges. How is that relating to what I should go and do as an epidemiologist? Because I'm not saying that, and then when you say R0, what parameter that, what factor that has to relate to hepatitis E virus transmission are we really talking about in this case? Now we are talking asymptomatic individuals. I have not seen any analysis done around asymptomatic individual parameters that associate with asymptomatic parameters. I have not seen any analysis done around it that now warrant the result that came out of it. So if you now go to next slide, finally, next slide, please. Yes, I see that we said deterministic HEV has been carried out, and then we started talking about the influence of asymptomatic individuals, which nothing has been done about. And then the last sentences, effective control strategy must combine abuse and mitigation. I don't know where that statement is coming from. Where did we get it from? This study of global stability, from this study of bioeducation, from the study of proximity and violence that we have from. Where did we get it from out of that study? Thank you so much.
Okay, thank you so much. Thank you so much, sir. To respond to the first question, which has to do with the question of interest, what we are basically trying to do here is to look at the genotype-specific hepatitis E virus, because most of the model we have is a general model, and hepatitis E virus is genotype-specific in the sense that the mode of transmission for genotype 1 and 2 is different from that of genotype 3 and 4. Genotype 1 and 2 is oral, fecal-oral route transmission, while that of 3 and 4 is zoonotic transmission. So what we are looking at is basically looking at genotype to gain insight into genotype-specific hepatitis E virus. So, and in most cases, we have some of these individuals that are not showing symptoms. They are infectious, they are not showing symptoms, and these are asymptomatic individuals. So we try to bring that into the model to gain insight into the transmission dynamics of this disease. That being said, the other question has to do with the analysis carried out. Here, what we did is an analytical study. This is an ongoing work. Let me say, bring that to the table, just to let you know that we intend to look at the numerical aspect of it, to use data to simulate the model. But what we've done so far is to look at the analytical work. So, and if we go back to the reproduction number, we will discover that because we use, I don't know if we can go back to the reproduction, to the arrow note, which represent the reproduction number. Okay. No, to the front, please. Okay. No. Yes, thank you so much. So if the robe here represents, I don't know if we can see the robe, 1 minus robe. 1 minus robe is a fraction of those that are moving to the asymptomatic class. And if we set that to 0, obviously it will reduce the basic reproduction number. So that is why we concluded that excluding the asymptomatic class, obviously the reproduction number will reduce because the arrow not 2 will be removed. And since it's addition we have here, once you remove that, that will definitely reduce the basic reproduction number because all the parameters are assumed to be positive. So that is why we made that conclusion. I don't know if I've answered your question, sir. Hello? Hello?
Thank you so much. I appreciate your response to the question. But you understand what I'm talking about here, that
Yes.
it should not be sufficient to just
Yes.
and expect to just know that something is happening. And I would also say, and maybe there can be deeper analysis that can be done around the symptomatic related parameters, to really see the shape of the transmission, as it has to do with either the reproduction number or the disease itself that's not. So, but just presenting this equation, not showing anything, it's not presenting that information. And I want to believe that it's not just what is intended, but what is written that matters. So it will be great that next time, even if it is to stay on this reproduction number and do more deeper analysis of this reproduction expression. A lot of things can come out of this. And then we can see how the shape, the geometry looks like, respect to those parameters. And then we can really talk about that as a result. Thank you.
Thank you so much. Thank you. Thank you.
Okay, we move on to take the second question.
Thank you, Doctor. Just one question for you. How did you validate this your model? That's my question.
Sorry,
Are you going to respond?
Hello?
Can hear you.
Yes, I can. Oh, yes. I think the question has to do with how do we validate the model. Like I said earlier, it's an ongoing work. We ought to have done this numerical simulation just to validate some of our analytical results. So that has not been done. So what we are presenting is just the analytical results. I think I have mentioned that earlier.
Okay, thank you for your response. So the next question will be that if you look at the model being analyzed, it's different from the original model.
Sorry?
So number one, when we get to that assumption, it reduces the model.
Sorry, I didn't get your question.
The model you ended up analyzing is different from the model in the control.
Is different from the model?
The original model you presented.
Yes.
So what led to that? Look at this model. Can you see this model?
Okay.
There is two ways. There's a movement from R to S at rate side. And there is also disease induced there in the symptomatic class. But right from the disease-free equilibrium, you set psi and delta to be equal to 0. So, and many studies have already established that these two parameters contribute to the model exhibiting backward bifurcation. If you now set it to 0 right from the onset of the analysis, you should be known to know the kind of result you are going to get. So I want to know the reason why you set those two parameters to be 0.
I don't know if I understood the question, but if you look at the bifurcation analysis we did, if you go to the bifurcation analysis that we sent the psi, please can you just move to that bifurcation so that we'll show you.
So, let's control this slide, please. A bit by bit, please. Yeah, move. Continue. Okay, continue. Okay, look at this slide. Where you have the proof. You say you prove the global asymptotic stability for a spatial A. For delta H equals 0 and psi equals 0. And my question is that, why did you do that? Because if you do this, it is no longer the original model you presented.
That is why I said it's a special case of the model. It's a special case for the model where we have our psi as 0 in the sense that if the loss of immunity is equated to 0. So it's a special case. It's still the model. That is why I indicated there that is for a special case of this particular model.
So if all your analysis is being carried out on a special case model, why did you give us that special case model as your real model? Because it has been shown in different studies that these two parameters contribute to the verification nature of the model.
Yes, yes.
So instead of concluding a further verification, if you analyze the original model in the presence of these two parameters, these two will be visited. Thank you.
So thank you so much. That is noted.
Any doubts, please?
Hello.
Please, can you go to your model? Can you go to your model?
Okay.
So, I throw some light on this model?
Okay.
Can you explain this model?
Okay, let me go through it. The first equation of that equation 1 represents the susceptible individual. And in that susceptible individual, we have the recruitment rate, which happens to be the lambda, plus those loss of immunity from the recovered state entering into the susceptible compartment. Now in the susceptible compartment, we have some individual living, which that is leaving the compartment to the exposed state. So leaving the exposed state. So we have the force of infection, which are given in ladder 1 and ladder 2, and the natural death rate. Then the second equation is the exposed state. When they are infected, when they are infected, they go through the incubation period of the exposed state, and the force of infections are given in lambda 1 and lambda 2. And of course, there is a natural death rate and the progression to the symptomatic state and asymptomatic state. I think there's something missing there. 1 minus the fraction there ought to be in E, which is moved. It's in order because when it's added, we'll have eventually be having a theta. Now the symptomatic, the third equation represents the symptomatic, the rate at which the entry and the exit of symptomatic infectious individuals. The rope there represents the fraction, those that are entering the symptomatic state. The theta is the transmission rate. Then, of course, the tau is the progression to the recovered state, and the natural death rate, which is the mu. The delta represents the death rate for the symptomatic, the death-related, the disease death rate. Hello?
Go ahead, please.
Hello, can you hear me? The fourth equation there is the asymptomatic. Asymptomatic, 1 minus, that is the fraction, 1 minus rho represents the fraction entering the symptomatic state from the exposed state. And theta, of course, is the transmission parameter. Then the epsilon there represents those entry from those moving to the recovered state, recovered compartment rather. The psi, like I mentioned before, is the loss of immunity. The mu also represents the natural death rate. Then we have the environmental compartment, which represents the viral load. Then we have the alpha 1 and alpha 2 represent the contribution
Yeah, go ahead, please.
Hello, Mr. Robert, are you there? Mr. Robert, Mr. Robert. Hello, Mr. Robert. The last thing.
I'm with you. I'm with you. I'm back. I lost
Okay.
connection.
Okay, please continue, sir.
Okay. So the file, which is the decay rates of the virus. So that is the equation there.
Okay, so if I can ask, what is the objective of this study? Small option. What's the objective of it?
That.
What is the objective of this work?
The primary objective, that is the overall objective of the study, is to develop a model that is genotype specific. That is genotype specific. That is why we brought in the environmental contamination or the environmental transmission routes, because genotype 1 and 2 is fecal oral transmission, which is different from that of genotype 3 and 4. So the overall objective is to develop a genotype specific hepatitis E virus. And in developing that, we incorporated the asymptomatic because we understand that some persons may be infections and not showing clinical symptoms. So that is the primary objective of the study. Analyze it.
So, one is that the objective is not clear. The objective should come from the biology of hepatitis E. Not talking about developing a mathematical model or something. And the methodology should be developing a mathematical model using the departmental deterministic model. Are you hearing me?
Yes, sir. I can hear you, Prof.
Okay. Number 2 is that you have not been able to show us those strains. And this is supposed to be a strain model, like you have 2 strains, genotype 1 and 2. The model did not picture that at all because the model only showed the symptomatic and asymptomatic, which we see in. I can use the same model for the factor cholera. So there is nothing new about the model that built based on the objective you have. So, I mean, you need to look at, by looking at different strains, but didn't appear. The biology says that we want to look at to study the effect of those 2 strains on hepatitis E, but you can see from the work it didn't show that. I didn't see any strains. Those 2 genotypes you mentioned, they are not there. This model, as I'm looking at it, can also capture cholera. So you have to go and sit down and look at that aspect. And number 2 is that the force of infection, under 2, so B1 IS, that is beta 1 IS plus beta 2 IA. So what is beta 2? Because like there's supposed to be a reduction factor and you have to put in on the asymptomatic. Because the rate at which asymptomatic is going to transmit is not the same rate and IS is going to transmit. So you have to do something. So the model is you have to sit down with this model. It's not yet featuring what you really want to answer. Are you getting it?
Yes, I'm with you, Prof.
So try to look at like IA, IS, it's not the same rate they transmit. Because when you say that you are talking about the rate of acquisition of infection. So the rate of acquisition of infection from the symptomatic is not the same as the rate of acquisition of the infection from the asymptomatic. So there's supposed to be a parameter you need to fix with that that will make it different from the other one. And then I don't know, like so you need to this aspect actually from the basis of your work, and then your aim should be clear. Your aim is not yet clear. So the model forms every other thing. Now, I'm not going to talk about the analysis because I'm not seeing that the model is more perfect. So you need to work on the model, try to put everything in perspective. And the title also does not showcase. Now, the title saying mathematical modeling of by position analysis of hepatitis B virus, genotype 1 and genotype 2. I didn't see anything that has to do with genotype 1 and 2, your model. So I think one of the reasons for this conference is so if you are not, I mean, if you are sitting the work, correct, and then you go back and improve on the work. Okay? I don't know if you have anything to say about that. Thank you.
Okay. Thank you so much, Prof. I really appreciate your contribution, sir, and it's well noted. But let me just say one or two. The genotype 1 and 2, it's different from strains. This is not, we are not looking at different strains. It's just, I'm looking at the mode of transmission. For genotype 1 and 2 is the same thing, it's not different strains. So for hepatitis E virus, the genotype 1 and 2 has the same mode of transmission. For genotype 1 and 2 we call it 1 and 2 in the sense that it's the same thing. One can be infected with hepatitis V virus that is fecal oral.
This thing, you have to remove it. Now, when you say genotype, you know the biology are confusing. You have to get the biology. So you are a mathematician. We are talking from biology perspective. You are mentioned genotype and genotype 2. It can't be the same from the biology. It cannot. So you have to get the biology right. For you to still be arguing it means that you don't have the basic understanding of the biology of hepatitis E.
Thank you so much, Prof. Thank you, Prof.
Now. So it's better you do it. If you are not talking about strength, why is it? What is it doing there? It's not useful. You just retain your asymptomatic area there, and then you leave out the genotype 1 or genotype 2, and then go and visit your model. You need to look at the model clearly.
Thank you so much, sir. Thank you.
Okay, so thank you so much, Dr.
Thank you.
Jola, for your comment. We hope that you'll be able to incorporate all these comments in your work. So thank you.
Thank you so much.
So, Dr. Sally, are you there?
Okay,
Dr. Sally.
Yes, sir.
Dr. Sally.
Yes, sir.
Okay, so I'll share your screen now. I'll share your slide now.
Your stuff will be showcasing, so get ready. Okay, your slide is already on, so we have 15 minutes for the presentation.
Okay.
Hello.
Good morning, good afternoon, distinguished participants. My name is Salim Mohammed Boboy. Thank you very much for the privilege you've given to me to present our work title, An AI-Driven Framework for University Program Recommendation in Secondary School Education. This research focuses on how artificial intelligence can assist secondary school students in choosing the suitable programs. Yes, introduction. I want to introduce. So, choosing a university program is one of the most important decisions in students' life. But unfortunately, so many students make it make this decision, make their own decision without structured guidance, especially in developing countries like ours here in Nigeria. This often results in career mismatch, low academic performance, and even dropped out. So, and our study explored how AI offers a scalable alternative, how artificial intelligence can help solve this problem. No, problem statement. In the next slide, I would like to discuss a little bit problems that in most secondary schools, especially in Nigeria, the career guidance services are either inadequate or completely absent. And where they are available, they are always limited by human bias, workload, and lack of up-to-date information for the student. So with this, I think these major ones are the ones that motivate the need for a scalable and objective solution. And the objective of this study is that we are to design an intelligent system. The main objective of this study are just to design an intelligent system that can analyze student data, recommend suitable university programs, and evaluate the system based on accuracy, based on performance, and also based on the user satisfaction. So, some related works previously shows that AI significantly improve educational decision support, but many existing systems relies on one AI technique. But our work differs by combining multiple techniques to improve reliability and the performance. Our work uses, that is to say, our work will use a hybrid AI approach. Now the methodology. We began by collecting student data, including academic scores and preferences. The data was cleaned and processed before building a hybrid model that integrates rule-based reasoning, decision trees, and the fuzzy logics. System architecture. The system is designed using a three-layer architecture. One, students interact with the interface layer, which sends data to the artificial intelligence processing layer, while the data layer stores the profile, rules, and recommendation for the career selection. And this is simply the existing system framework, whereby if you can see the flow, the student will just start, and the student will just seek guidance. You will just meet a school counselor, a friend, or a school counselor for that selection matter. The decision on interest and strength is being carried out. The counselor may just probably, based on his own interest of choice, will suggest a course, and the student will just make a decision and opt into a course that maybe he's not ready to do based on his own academic performances. So this is simply the existing system. And the next, this is our proposed system, whereby student will just impute his interest and scores, his course of interest, and the scores in most of the courses that he have imputed. The expert system will now do the analysis of the data imputed by the student, and it will generate a suitable program options that will be available for the student based on the imputed data that was analyzed by the system and the scope. Student will then sit down and select any of the preferred program given out as an option by the generated system. So this is a decision. This is a decision-making flowchart. This is a decision-making flowchart. The implementation of law. The implementation of the proposed system requires software, hardware, human, and data resources. And this decision-making flowchart, student will log in, he will input his own academic and interest data, complete aptitude test for some few minutes, and data processing will take place. Then from there, the system then evaluate input against predefined rules and identify matching universities program. If the match is uncertain, the system prompts the additional input to the refined recommendation based on the analysis. The system either suggests a suitable program or recommends further career exploration. The flowchart ensures logical and structured decision making, improving accuracy. And it also minimizes error and bias by following standardized rules. Finally, the system provides students with optimal career choices, helping them make informed decisions. Then, a requirement process. The implementation of the proposed system requires software, like I mentioned earlier, hardware, and human with the data resources. The software components include Python, TensorFlow, MySQL for database, and web-based user interface framework. The hardware requirement includes servers, personal computers, laptops, that is like laptops and other devices, and network infrastructure to support real-time processing. Additionally, trained personnel, including system developers, data analysts, and administrators, will be required to ensure proper development and maintenance. Instrument used for data collection. Data for this study was collected through questionnaire, interviews, system logs, and digital archives. Questionnaires was used to gather insight from students and staff regarding their expectation, while interviews with key stakeholders was provided qualitative data on the current system limitations. System logs was analyzed to identify trends, and digital archive serves as a source for training the AI model. Now, database reprocessing. These are the features in the database and their own details. The student ID, the age, gender, academic performance, subjects, and career interests. Like, these are the details of each feature that is being stored in the development of this framework. And it was all assigned with some various numbers. Method of data analysis. Method of data analysis. Our data has undergone cleaning, transformation, and feature selection to remove inconsistencies and improve model accuracy. Missing values like the 0 and 1s in the previous database, using imputation techniques, and irrelevant data was eliminated. Feature selection techniques such as principal component analysis, PCA, was applied to optimize input variables. And model development, the development of this system involved building the machine model that recommends suitable university program for secondary school students based on their own personal, based on their own academics, and based on their own psychometric profiles. An expert system was developed using supervised machine learning techniques to recommend suitable university programs for secondary school students. The data set was processed categorical encoding, normalization, and missing values cleaning, and it was being split into training and testing, which is 80% for the training and 20% for testing. Model evaluation. The developed career guidance system was evaluated to determine the effectiveness of the machine learning algorithm, support vector machine, random forest, and the CNN, convolutional neural network, in predicting appropriate university program for students secondary school, for students of the secondary school. The data set was divided, like I mentioned, 80 and 20% for the training and testing. Evaluation metrics. The following matrices were applied from 1 to 4. Accuracy, proportion of correct prediction. Precision, proportion of correctly predicted program categories out of all prediction. Recall, ability of the model to correctly identify the actual program category. an F1 score for harmonic means of precision and recall balancing both measures. The results: 1. Support vector machines, random forest, convolutional neural network, all of them has been achieved in getting out this framework to be a successful one. As you can see, this is a result whereby the implementation of the ETSA system produces a functional web-based application that is capable of interacting with the user. As you can see from here, it can you can take a quiz as a student after you might have logged in. Then let's see the next page. So here, immediately a person or student might have clicked to ask of some few of optional questions where like what is your interest? Is it mathematics, physics, this and that you select? What is your dream career? What do you want to be in future? Your preferred learning style? Is it virtual learning or on-campus learning? So and the rest of them. This is a sketch, a snapshot of where, assuming you have filled it and everything has been intact, so you submit it, you get a pop-up message of window display saying the recommendation result, whereby it will show you your area of interest, best subject as imputed and made being analyzed by the system, and simply to recommend you some list of courses that you are to go. Like for this one, you can see pharmacy, medical laboratory science, and the rest of them. So also another results with a different input from a user will show a different recommendation of university program. Like this one, you can see after giving it input of different data, it recommends political science, law, public admin. And so also, if you can go to the next results with the provided of different input data by the student, it also gave another different recommendation whereby it shows you can the recommended university programs, accounting, business admin, banking, and finance. And that is it. That is how it goes. Different input data, different results you are getting from the system. So the model evaluation of the career guidance expert system yielded a promising result across functional, performance, and user experience criteria. The summary of results from each evaluation dimension is as follows. The system was tested using a variety of input combination from 30 students covering diverse interests and academic strength. The rule-based inference engine correctly matches this input with relevant university programs in 28 out of 30 cases, indicating a functional accuracy rate of 93%. These results were further validated through comparison with school guidance counselor recommendations and student self-perception of academic strength. The model evaluation demonstrates that the expert system is both effective and reliable for guiding students of secondary school in selecting their own university programs to study. Yes, this table shows performance matrix and its results. Average system response time is 1.2 seconds per query. The database for each query performance, the average response time is this 1.2 seconds per query. While successful rule match is 98% eligible student input, inference accuracy as 93, and average session duration as 3.5 minutes per student. This is to show you that the system is as fast as possible. User evaluation criteria, ease of use, like this is the average score of rating that was being typed out. You can see average use of this is 4.7, accuracy recommendation, usefulness of career decision making, and interface design and responsiveness, overall satisfaction, is carrying 4.6 rating. Now, discussions of results. The development and implementation of this framework demonstrates significant potential gap between secondary school and university program selection. From the user evaluation and system performance analysis, it was observed that the system effectively matches student academic strength, personal interest, learning style, and preference to suitable universities or courses. This results undergoes the relevance of using AI, especially rule-based expert system, to assist students in making informed decisions regarding their own future on the academic professional line. One of the key findings that was the system's ability to replicate the role of human guidance instead of a physical guidance and maybe misinterpretations of words. This system plays so many percentage out of 30 cases, as we mentioned, the system recommendation align with either school counselor suggestion or the student academic interest in 93% of the cases. This alignment not only validates the correctness of the knowledge base and rule embedded in the system, but also reflects its ability to interpret nuance users' input effectively. The success of the rule matching process further indicate that the decision logic used to correlate input parameter with career path was logically and contextual. So in conclusion, I would like to say that this research of this framework, that the expert system is not only viable but also highly effective as complementary tool to traditional counseling. The rule-based architecture proved capable of simulating expert decision-making processes with a high degree of accuracy, and it has its own simplicity, user-friendly, and very effective in the students making their decision adequately. Thank you very much for listening. I highly appreciate it.
Please, let's take it back.
Thank you, sir.
Okay, number one, number two, number three. So we have three people that want to ask questions, so be prepared to respond to their questions. Okay?
Okay, sir. Okay, Prof. Okay, sir.
Okay. Thank you, Mr. Presenter. Please, can you take us back to your title page and the objective? Okay, you said an AI-driven framework for university program recommendation in secondary school. Okay, it's your objective page.
Yes, sir.
As the fields you talked about, you want to build a model, and then there's something like that. Design an AI-based career guidance system and so on. Okay, please, I want to know which model have you designed from all of what you said in the AI. Watching to see all through to know the AI system individual, all of that. But I don't know, talk to us. What model did you actually use in the AI? Or what platform? I don't get. Sorry.
Thank you very much for this question. Like I said, the main objective of this study is just to design an intelligent system that can analyze student data, recommend suitable university programs, and evaluate the system based on accuracy, performance, and user satisfaction. That is why when the system is being on its own peak, it's simply a framework, and it can also serve as a system to the persons that are in the use of it in their own need for the satisfaction for an ultimate objective. That is, like I said in my objective, it will be as an AI-based career guidance system instead of our own local counselors in the schools or as parents or brothers. This AI can serve as a career guidance system framework or and also it will analyze the student academics and personal profiles. Like I said, if a student is to discuss with his own friend that I'm much interested in physics, I like mathematics, I don't like this, I like that, so it will not be as much accurate as the one that the system will receive and will do its own analysis based on the imputed data that is directly made by the student. And it will also to recommend the suitable university programs. Already, list of programs and the margin point that may be raised from the student has been imputed in the database. So any analysis that is being matched by a particular program that was being set, it will pop up for the student to select. Then to evaluate the accuracy and the usability of the given option compared with the input data being made by the student at the use of the system or the framework. I mean.
Okay, no, that's good. Okay, second question.
Thank you for the presentation. I just want to ask two questions quickly. The first question is, you speak about your flow diagram. I was just seeing how, yes, the next one. Next. Okay. Yes. I was expecting that there should be a feedback where the choice, or if the suggestion of the AI is not what the person wants, it will go back and the process will continue. I don't know. Maybe you may explain that better for me. So the next question is, you mentioned about some algorithms, SVM, topology vector machine. I think you mentioned decision tree and another one. Which particular algorithm did you resolve the use in this work? And then the last question is, which programming language did you use to develop your model?
Okay, I think I will start by explaining. Please, can you go back to the decision making flow chart, please? Yes. As you can see, this is a decision making flow chart. Holistically, this decision making flow chart, it's outlined a step-by-step process used by the external system to guide the student. If you can see, it starts with the user entering their academic scores. That is the students entering their own academic scores, interest, and the career aspiration. The system will then go and evaluate input against predefined rule to identify matching programs. If the match is uncertain in the next stage, the system prompts for additional input to the students to refine recommendation. But based on the analysis, the system either suggests a suitable program or recommend further career exploration. So this flowchart ensures logical and structured decision making, while also improving its own accuracy. It minimizes error and bias by following the standard rule that was being predefined by the system to adhere. And then finally, the system will then provide the student with optimal career guidance or career choices that will help him to be informed for the decision according to the data he imputed earlier from the input academic and interest and down to the student provides feedback. So, and the next one, I think the software component, like I mentioned previously, is include a Python and MySQL, as I showed you in the table, and the programming language is Python. Hello, sir.
Okay.
Hello.
All right. Thank you, Dr. Ubori, for the presentation. So, my first question, I saw that you incorporated gender as one of the features of the system. So I want to ask, what will be the influence of gender in the choice of the career guidance? That's my first question.
Okay.
Do you get
From
that?
our
All right.
yes, from our data pre-processing, we have already identified first six features where gender is among, and in our assigned values, we assign. Computer only understands zeros and one, so we have assigned 0 to represent female, while 1 represent male. In some cases, in some part of this country, Nigeria, the developing countries, most of the females, like, they don't always go for, let's say, engineering, like civil engineering, mechanical, and others. Mostly, you will see that male are more in that kind of courses. So, in this case, male or female is also considered in the system in order for the system to enable you to provide the guidance based on also the genderism that you are applying to the system. But it is left for you to, again, to refine your own choices as the student in the input to say, okay, even if I am this, I would opt for that course. Like medicine, like accountancy and other courses, business administration, you can find out females, males, and all other genders goes there. Like journalism, most of the males you find out less in that field, but females are higher. So that is the reason why we assign gender in the data pre-processing sector.
Okay. Yeah, I think you have to update because times are changing. Some of these traditional roles that are meant for men alone, you now see women in those career paths. So you may want to look into that, just like the engineering you mentioned. If you go to a typical engineering universities now, you see quite some female students that are studying to become mechanical engineers and all that. So we want to also revisit that. Then there is this performance metric table you display. Media, can we go to down, down, down? Okay, yes. So I don't really get this. Can you clarify? Especially the second row. What do you mean by that? Are you there, Dr. Boy?
Sir? Yes, sir.
Hello?
Okay, yes,
Can you get
I can see. Yeah, this is a table of performance metrics, like the performance of the system. The average system respond. Some of the systems responded very slow. Some of the system responded averagely, while others responded in a very slow time. But this framework has been designed in such a way that its response time is in 1.2 seconds per query. If you query, it will take a lot of time in some system to give you response, and based on their own memory capacity and the type of processor and the number of codes that you use in building the application or the framework. But here, the successful rule matches is almost 100%. That is 98% of eligible students' input. That is how it was being carried out. And the accuracy of its own inference is also in a high standard percentage of 93. And the average session duration is estimated to be as in 3.5 minutes per student. Like, every student might wishes to do his own in an eager time. Like, we know we are all in a hurry. So developing a system of slow and some other system that lack early response time. It's like it frustrates and it bring out incompetence in getting out what it's required to be gotten.
Okay, thank you for your responses to those questions. So I think from here we have captured all the questions. So we appreciate you. Thanks for your presentation. So this ends this talk.
Thank you very much, sir, for the opportunity you have given to me. I highly appreciate it to you all, sir.
Okay, thank you so much. Just an announcement or two announcements. First one, I want to appreciate all of us for staying true to this point, and we'll continue. But one thing we have seen, and you saw Prof had to be going around to stop some of us from pressing our phones and laptops, and majorly laptops. This, as I said, also yourself and talk.
Dr. Jubri, are you there, sir? Hello, Dr. Jubri, you can unmute yourself and speak, sir. Hello, sir, are you there? Okay.
Hello.
His name is Kamagonto. Kamagonto, are you there? Hello, Mr. Kamagonto. Hello, Kamagonto, are you there? Mr. Kamagonto, are you there?
Is he there now?
Okay, Mr. Kamal, are you there? Mr. Kamal, please unmute and speak. Yes. So, Mr. Kamal, we have your presentation now. So please unmute yourself and speak. So I'll display your slide right now. So your slide is on comparative finite elements evaluation of TICAI. Am I right? Please, we can't hear you. We can't hear you. You are not speaking. Mr. Kamal, you are not speaking. Hello, Mr. Kamal, please work on your microphone. I don't understand. We can't hear anything you're saying. I can see you are moving your mouth, but I can't hear anything. Mr. Kamal, what's wrong with your microphone? We can't hear you, but I'm sure you can hear us.